This lizard's leap changed the skies forever. How 200 million years of evolution created biological fighter jets. When we talk about pterosaurs, most people are familiar with these creatures. With their enormous heads and bizarre bodies, pterosaurs the size of small airplanes once dominated the skies as the largest flying animals in history. This has led some to question their existence, with many believing they're merely products of human imagination. After all, the idea of such massive creatures launching themselves into flight seems laughable to us today. So let's explore the evolutionary history of pterosaurs. First, it's important to understand that while pterosaurs ruled the skies during the age of dinosaurs, they weren't actually dinosaurs themselves. They were flying reptiles. We can find clues to their origins in modern reptiles, like the Draco lizard. Much like its ancient relatives, this little creature primarily feeds on insects. Since most insects can fly, this forced the lizard to adapt. What appears as a simple leap actually involves fully extending the wing-like membranes on its sides, allowing it to glide impressive distances. This demonstrates how reptiles first took to the air. Some might argue this proves nothing substantial, so let's examine more convincing evidence. In 1828, Mary Anning, a working-class British woman, made a groundbreaking discovery on the coastline, fossils that initially appeared to be an ordinary small reptile. However, through meticulous reconstruction, an extraordinary creature was revealed. Detailed examination of the fossil characteristics showed it was a winged reptile. As more fossils of similar species were subsequently unearthed, they became collectively known as pterosaurs, or flying lizards. Around 200 million years ago, when dinosaurs were just beginning their domination of land, smaller reptiles evolved these unusual features, both to escape predators and to better hunt flying insects. Thus appeared Dimorphodon, which lived in trees to avoid ground dangers. Though they had developed wing membranes, their clumsy flight suggests they struggled mightily in the air. Short flights required tremendous effort and were fraught with danger, as their poor flying skills often led to collisions. Falling on land was bad enough, but plunging into water meant certain death. Their bodies would sink, be covered in sediment, and over millennia become the fossils we discover today. As more pterosaur fossils are found, we gain clearer understanding of these remarkable creatures. Some claim these are just penguin or rabbit skeletons, but no paleontologist would waste time reconstructing existing animal bones. These early pterosaurs laid the foundation for an extraordinary aerial dynasty. Life evolves under environmental pressures. 50 million years after the first pterosaurs appeared, Earth entered the true age of dinosaurs. In China's Liaoning province, a special pterosaur fossil was discovered, Darwinopterus. These exceptionally preserved fossils show clearly elongated skulls with sharp teeth and long tails, representing significant advancement from Dimorphodon. Their larger heads and sharper teeth indicate carnivorous diets, requiring more advanced flight skills to become true predators. While adept in air, reconstructions show they remain clumsy on ground, with their long tails and extensive wing membranes connected to their toes, hindering movement. Their claw structure suggests they were better suited to perching in trees than walking on ground, making them a crucial transitional species in pterosaur evolution. Later pterosaurs showed major breakthroughs. Their tails shortened and wing membranes became more refined, allowing better ground mobility. Fossil interpretation isn't as simple as I've described. Over 200 years of paleontological study, countless researchers have dedicated lifetimes to studying single animal footprints. Numerous pterosaur trackways reveal details about their movement patterns through footprint depth, shape, and stride length. These short-tailed pterosaurs lived in groups and moved on ground with dramatically improved efficiency, a milestone achievement that expanded their food sources. Over subsequent millennia, short-tailed pterosaurs spread worldwide, hunting in various ways. Fossil evidence reveals their diverse diets through distinctive head and tooth structures. This very diversity allowed pterosaurs to thrive alongside the dinosaur dynasty. The appearance of Pteranodon was particularly striking. These pterosaurs grew enormous, with average wingspans reaching 8 meters, becoming among the most common pterosaurs of their time. But how did such massive creatures achieve flight? We'll explore this mystery in our next installment.